we're going to derive one of the equations of motion by graphical method. So the equation is position time graph, that is S is equal to ut plus half at square. So that's our equation. For that, we need to begin with a velocity time graph. So the object has a non-zero initial velocity and it's increasing, it's accelerating at a constant rate. The initial velocity is u starting from point A, and this is point B. The initial velocity is u. The final velocity would be this, and the final time would be this. So all this is dotted line, indicating it's a projection of the point. The final velocity is v, and the initial velocity is u. Initial time is 0 and the final time is t. So the object is moving from 0 second to t seconds, having an initial velocity of u to v. This would be basically your ay, and that will be your by, projection of a and b onto the y-axis. That would be your ax, and this would be your bx, projection of a and b onto the x-axis. So with this in mind, let's move on to finding s, expression for s. How do you find s from a velocity time graph? S is nothing but displacement. So we learned this before, that area under the graph in a velocity time graph gives displacement. So basically S is equal to area of AB, BX and O. If not, I'll call this as C and this is D. So ABCD. Now I can find the area of ABCD by dividing it into a triangle and a rectangle. So area of ABCD, which is nothing but area of triangle ABP plus area of the rectangle APCD. So area of the triangle is half into base is AP over here and height is BP plus length is DC and height is AD. So it's very clear from the diagram that AP length is equal to DC because it's a rectangle and it is from 0 to T. So basically it's T. BP is from V to U, that is V minus U. DC is where? DC is over here, that's T, and AD is U minus 0, that is U. Now we want UT. Okay, UT we have, half we have, we don't have a, T square, in that we have a T. So if I substitute P minus U being equal to A into T over here, right? Or let me do another job. So we know that V is equal to U plus AT. Let's substitute that. So we have S is equal to half into T into U plus AT minus U plus UT. So we have U and minus U getting cancelled, and you have half into A into T is AT square plus UT, and that would be your formula, right? A very small set of substitution and everything, and you can see it's a simple idea that is expanded to this formula. So as a write up, you would need to write this amount. First is the graph and the description of the graph. Consider a velocity time graph of an object that moves under uniform acceleration. Let the initial velocity of the object be u, and that then increase that to v in the time interval t, so 0 to t. Drop perpendicular BC BE onto time and velocity axis and drop AD parallel to OC, where D is a point on BC, right? Then we'll tell OCBE, OCBE and OCDA are rectangles. As the opposite sides are of a rectangle are equal, we can tell all of these respective sides are equal and they have the value of u, v and t. And then we'll be talking about, let S be the distance covered in time t. So from the figure, as in a VT graph, the area under the graph is the displacement of the object. S is equal to area of, this implies S is equal to area of OABC. That could be divided into a triangle and a rectangle, and everything else is whatever we have discussed till now, right? So this is your write-up and derivation. So if someone wants to have any idea or taken from here, you can do so now, and this would be your exam answer.